Vamos começar com alguns exemplos, então. Maybe, David, you can start with a few examples. I know David has a hard time box, right? So
actually,
we can start with your example.
I rearranged things so I'm a little more flexible.
Okay. Okay.
But I'm happy to start, sure.
Cool.
Okay. So here we have a function, and this is a function that adds numbers together. But as you can see, it's clearly broken, because if you're familiar with Clojure, the signature for the function says we'll take any number of numbers, but we're only going to apply plus to the first two numbers, right? So this is broken.
You're just adding the first two numbers in a sequence.
That's right. That's right. Mm-hmm. And what it suggests it's doing is just adding whatever numbers. So we're developing this, and we write a test, and this test says, okay, we'll take the first two numbers, and we'll give it two numbers, and that works. And you can see in the upper right, after I evaluated that it returned true, so it passed. And then here, if we do one with three numbers, this one will fail, right? And you can see in the lower right in my REPL, it output the failure. So, this is a very simple example, but we do this all the time. We write a function, and then we write some tests. And if we're doing TDD, we write some tests, and then we write a function. But it's only as good as the tests that we think of. And so, like in this one, the second test happened to expose the bug, but we just kind of got lucky about it. With that in mind, we can test like a more complicated thing, like the fact that addition is commutative, which means that if you it doesn't matter the order of the arguments. So sum 1, 2 should equal the same thing as sum 2, 1, and that passes. And of course, we could do this a little more programmatically by taking some input and then applying some to the input and then applying some to the reverse of it. And again, it passes if we only have two numbers that we're handing to the function. But if we handed 3, we're going to get another failure, right? So this is all fine. I mean, this is sort of how we do things in example-based testing. The idea of generative testing is that we're going to generate the inputs instead of hand coding them. So we use these things that are called generators. And so I'm using the Clojure test check generators, Clojure test check library and the generators namespace. In it, there is something called a small integer generator. And if we evaluate that, we could see that it represents itself as a map with a gen key that's got some function attached to it. And that itself is a generator. Then we could pass that to the generate function, and it will generate a small integer. And you can see in the upper right, every time I evaluate this, it's going to generate a different integer. And then now we can also, gen vector itself is a generator. So this is a generator that will generate a vector of small integers, and we can use that to generate arbitrary length vectors of small integers.
So you composed both of them on line 43. You're just composing generators that exist. Okay.
And there are a number in this library. There are a number of generators that are composable like that, and there are also generators that allow you to compose with arbitrary functions where you can modify the output in some way. Okay. I'm not going to get into all that detail right now, but just so that you know that it's there. Any other questions before I go on? So far, so good? All right. Yeah. So, yeah?
No, yeah, it's okay. We can go on.
So what we could do is use a generator now to generate inputs to a test. So here in this example, what we're doing is we're going to generate vector events and then apply some events and then apply some of the reverse events and see if that's equal. And we could see that it's not. And in the lower right, in the REPL output, you can see that we had generated, it looks like there's 9 or 10 elements in there. And we know that we know the big secret that anything more than 2 is going to break it. Now, with a generator like this, once in a while, it might actually generate a small enough vector. Yeah, so that time it generated an empty vector, and the test would pass in that case. So the nice thing about having it generate the inputs for you is it's likely to generate, it's more likely to generate some input that will expose a bug than you are to create yourself. All right. And then, of course, but doing this one at a time is a little tedious. So there's also a sample function. The sample function takes a generator, and when you evaluate that, what we're getting is a sampling of vectors of small integers. And so we can use that now. We'll do seek over those and do the same thing we did before. I'm going to clear out the REPL just so you can see all the new input clearly, or output rather clearly. So here we generated an empty vector and the test passed. Here we generated another empty vector and it passed. Here's 1 and it passed. When we get down here, we generate a vector of 4 elements, and you can see at that point it fails. And so if we're looking at this output, it's like, okay, well, that's interesting. Like all these vectors smaller than 4 passed, and this one that had 4 in it failed. And we could keep looking down, and we see some more. Another one passes, and some more failures. So we could scan all this and sort of start to hone in on the problem that we're only looking at the first two elements. But we can do better than that. So in this closure test check library, there is an implementation of quick check, which is a library designed to do this kind of testing, but give you really interesting feedback. So here we're using this def spec, which takes a property, and a property is, in the abstract, it's just like the fact that addition is commutative is a property of addition, right? And so this is referred to as property testing. So what we're going to do is we're going to say, okay, for all ints, which are going to be vectors of small integers, we want to say that, the sum of those ints is equal to the sum of the reverse of those ints. All right, so I'm going to just evaluate that, and now we have that as a function, and we can run it. One way to run it is to just invoke it directly. So I'll do that, and you can see some interesting output in the upper right buffer. All right, so one thing that we see is that it ran 4 tests. Now, it will actually run 100 tests by default unless it encounters a failure, right? So what this is telling us is that the first 3 tests passed and the 4th one failed. And the value that it... What, go ahead.
Could you run it again? Maybe it...
Yeah, sure.
Give a different number?
Yeah. Run it again. This time it ran 7 tests.
Until it found a failure. Okay.
Right? And here, we'll do it a few times. This time it ran 8 tests. Now look at the what's bound to smallest. See, there's that vector of 0, 0, and -1.
Line 8, yeah.
On line 8, exactly. So I'm going to run it again. And this time the smallest was 0, 0, and 1. And this time it was 0, 0, and 1 again. And this time it was 1 and 0 and 0.
You can use your mouse there to show us as well.
Oh, yeah. Oh, yeah, okay. I'm talking about what's right here on line 8. So let's look at what's going on there. It's pretty interesting. So I'm going to run it one more time so that we could just see all of the output in the REPL just from running it once. So this time you could see here it says we ran 5 tests, and that the 5th test failed with this value of a vector of 4 elements. Then we get this thing smallest. So what is that about? So let's take a look at the output. So here on line 3, where I am in the REPL, you can see the first example was an empty vector, and that one passed the test. The second and third were also empty vectors. The third was a vector of 0, and that one passed. And then the first one that failed was this one here on line 15, the vector of 2, -4, and 2 and 3. Well, it didn't stop there, all right? So if we look beyond that, here's another test where it's just an empty vector, and here's another couple of tests with 2 elements, and here's another one with 3. We all know that this one probably would fail. So what's happening is the def spec function it's doing this process called shrinking, which is basically it keeps running tests with, and whenever a test passes, the next test uses a bigger value. And so a bigger value could mean a larger vector. In this case, it could mean like a vector of more elements. It could mean that the numbers within the vector are larger. And then every time it fails, it runs a smaller value. And it goes through this process until at some point it figures out somewhere in here, we're going to see 002 and 001 here on line 81. Now, at the point that 001 happens and it fails, it keeps going and it's trying smaller and smaller values. And it decides, okay, 001 is the smallest value that can cause this test to fail. And then it hands us that here as the smallest.
For each generator, it has sort of this notion of what a more complex value would be, or in a simpler, bigger value or a smaller value would be?
Yeah, there's this notion of size, which is going to mean different things depending on the data type, right? So for like a data structure, like a vector or a map, it'll have more elements in it. For a string, it might be a longer string, but it also might have more complicated characters in it. And you'll see this if you generate like 100 strings, you'll see pretty normal looking strings. I mean, they don't look like actual words, but then if you generate 1,000 of them, you start seeing all these crazy characters with escape keys and all this. And that's a great way to really stress the function that you're trying to test.
Nice.
So the one other thing that I want to point out here, actually, I'm talking and talking. Any other questions?
So I mean, this seeking of the smallest example is just like the binary search that helps you debug. If we didn't know where the bug was, with that smallest example, we'd quickly find it, right?
That's
instead of looking for 7, the vector with 7, what's going on?
And not only is it a vector of 3, but it's a vector of 3 where the first and third are different, right? If it was a vector of 3 values where the first and third vector were the same, it would pass the test just by luck. You know what I mean? Because we're just reversing, and it's taken, like if this was 1, 0, 1, it would take 1 and 0, and the sum would be 1, and then we would turn it around, and then it would get 1 and 0 again.
Okay. The property would hold.
Yes, in that case, right? So this is the smallest example by this definition of what smallest means that we can use to cause the test to fail. And so it can give you a lot of insight into what the bug really is that way. And we don't have to look at, like, I walked you through all of this output, but under normal circumstances, you're not printing stuff out, right? All of that, goes away. And then if we run this, I'm going to run it one more time now, right? The only output, well, we did get some output in the REPL. What was that? Oh, this is just failure notification.
It just shows the...
What's that?
It was showing us the smallest example, right?
Oh, it does. So usually when I run these things, I just look at this output, right, when I see a failure. Go ahead.
I was going to ask about the seed thing. So this is pseudo-random, and we can replay the same examples, is that it?
Exactly. So you can see the seed right now on line 11 starts with 16. I'm going to save that here in this var seed so we can use it again. Right there it is. And then we can run the test again, and you could see now the failure. Every time I run this, the failure on line 12, it's the same failure. It runs 7 tests, right? So yes, the only thing that's changing is how many milliseconds it's taking to run. It's somewhere between 1 and 0. Pretty damn fast. So, and then the nice thing about that is now we can go and we can fix the test. We can find the bug, we fix the bug. Oh, interesting. There's a bug in my editor. All right. And now we run it again and using that same seed, and now it passes, right? So that's a good way to double check that you're doing it. Now I only ran it 10 times, right? You can see I put that 10 here. By default, when you run it, it runs it 100 times, right? So I just evaluated addition as commutative, this function, and you can see it says 100 tests. You could pass a number to this and run it 1,000 times, or 10,000 times. That takes a little longer. You had to blink. So that's another useful thing about this tool is you could kind of dial in. Like sometimes when you're dealing with big data structures, the more you generate, the longer it takes, and you don't want these things to, you don't want 50 of these tests running and have them take a bunch of minutes. You still want it to be fast. So you can dial in like a number based on your understanding of the problem, your understanding of the input space, like what possible values there are in the domain, and set it to a reasonable number. 100's a good default, which is why it's the default.
Do you ever use a result and fix it as a regression test, as an example?
Or do you fix the seed? Yeah.
No, neither of those. The idea here is, I mean, it's already a regression test, right? It already found the bug, and then we got it to pass. So theoretically, if that same bug reemerged, this would fail again, right? So you don't need a new test to memorialize that. This already covers it. That's the idea. I mean, I've seen processes where people tie code closely to cards in their tracker, like Jira, and so then it's a business requirement that there's a test that's associated with that if you have that kind of very heavy process. That's up to you.
But you haven't had to rely on like, no, since this seed found that bug, we're going to just add the seed whenever we run it, and we're going to keep it, because I seem to remember we discussed a little bit some of the criticism around, well, what if it generated 100 empty vectors, right? There's a chance that could happen. You never find a bug. So,
so this is why, okay, that is not 100% without merit, right? It could happen. The likelihood of that happening is super, super, super low. And also, if that's your concern, then dial it up to 500, With things like generating integers and vectors of integers, it's going to go pretty fast. So in terms of saving the seed, I don't think that's necessary. I think it's useful when you're doing this kind of debugging. But remember that it was failing consistently for us before. I mean,
so normally in your experience, when it finds a bug, it's easy to find the bug again. It's not like a really rare bug that only happens in rare cases.
I mean, the only times I've seen cases where the generative test is failing intermittently itself is where there's just like too few examples to generate something to trigger the bug. And I don't know that I've ever seen that with the default setting. I think I've seen that where someone decided to try to make it more efficient by reducing it to 50 examples, and then it didn't generate something that triggered the bug in that set.
And David, in your experience, have you used this type of testing more to like drive your design and your solution, or as, you know,
not at a high level? Like, I mean, I've used it. I use it more to help me refactor functions. I mean, this is really a tool designed to work at the function level. It's not designed to work at like the application level. Yeah, you can imagine, you know, like, so at Nubank, we have this integration testing tool where we simulate all of this interaction with the outside world, HTTP requests and messages in our queuing system. And, you know, all of that stuff takes a little bit of time to run. Takes a little bit of time to set up and run. And so if we were running a generative test in that case, like this kind of property-based test where we're generating 100 or 500 or 1,000 examples, we'd probably not, you know, we'd be sad that it was taking so long. And it's also not a great fit for that because you've got so many moving parts in a scenario like that, right? I mean, I think it's good to generate values in those tests, but like generate a value so that each time it runs, it generates something different. Like, you know, we have tests with dates in them, and a classic mistake is to hard code a date, and then like suddenly you find that there's some mysterious date that, you know, triggers some bug because you didn't account for leap year, or you didn't account for São Paulo decided to change the holidays this year because there's a pandemic, you know, things like that. And so the business days are different. So it's good to generate values in tests, but I wouldn't use a tool like DefSpec for that personally. I'm sure there's someone in the world who has great success with that. I just haven't yet.
Bom, é o seguinte, aqui é um exemplo bem simples até de uma das ferramentas que a gente utiliza aqui com o Node.js, né, que é Striker Mutator. Eu já vou falar um pouco mais a fundo sobre isso. Mas o que seria uma mutação, né? O que a gente, como que agiria, né, a mutação dentro do nosso código? Ele iria vir aqui modificar, por exemplo, que nem eu já tinha falado, né, um operador ou um valor final, um operador lógico, ele iria executar esses testes. Então, eu tenho aqui um teste só em cima desse cara aqui, né? Que para aceitar termos tem que ser, aqui no caso só está testando que ele tem que retornar falso quando for menor de 18 anos, né? Esse aqui é só um exemplo mais simples, depois eu tenho mais alguns aqui. Mas basicamente ele vai fazer esse teste em cima aqui desse código. Ó, esse teste, depois que ele modifica, então eu vou pôr uma mutação aqui, executo o meu teste. Falhou. Quando ele falha, aqui eu tenho um mutante morto. Beleza, é o que eu estou esperando, porque eu estou modificando o meu código, né? E é isso mesmo que eu espero, que falhe o teste. Porém, se eu modificar só para o maior, que é uma mutação também, ele vai continuar passando o teste. Aí eu tenho um mutante vivo.
Tem algumas mutações no código que o teste pega e algumas que o teste não pega.
Exatamente. E aqui eu tenho, como passou, mesmo modificando o operador lógico, eu tenho um mutante vivo. O que isso significa? Significa que eu só estou testando um dos cenários aqui. E não, o caso, para eu matar esses mutantes, para eu acabar com esses mutantes, eu teria que também testar quando for igual a 18 anos, quando for maior a 18 anos, eu tenho que contemplar os mais diversos cenários, para enriquecer meu teste de uma maneira melhor. Agora para um exemplo mais... só que assim, se a gente fosse inserir essas mutações manualmente no nosso código, ficar trocando lá e rodando os testes em cima para ver se ia quebrar, isso seria inviável, né? Então é um esforço manual muito grande, por isso a gente acaba executando essa lib aqui, que é o striker mutator, e exige uma pré-configuração dela, né? Aqui eu coloquei só para ela... você consegue instalar ela bem tranquilo com npm mesmo. Existem também outras libs para Java, PHP, também Ruby, relacionada a testes de mutação. E aqui eu consigo configurar quais os arquivos que eu quero que sofram mutações. Então, por exemplo, aqui eu coloquei esses 2 arquivos, né? Eu enxuguei um pouco aqui para ficar um pouco mais rápido o tempo de execução para mostrar para vocês aqui. Mas daria para rodar em cima de todos também, todos os arquivos que eu tenho. Então tem outras configurações também. Como ele utiliza bastante do processamento, você pode fazer configurações de concorrência, de timeout, entre outras, né, que a ferramenta também oferece para a gente. Mas o principal ponto que eu quero mostrar para vocês aqui, eu vou executar o teste, essa é uma aplicação com CRUD, bem simples, mas é para comparar a questão do coverage com o que temos no nosso resultado do teste de mutação. Então eu executei todos os meus testes aqui para coletar o coverage. Se eu abrir aqui...
Deu 100% de coverage, é isso? Uhum.
Isso, está 100% de coverage. Por exemplo, se eu for aqui na parte de adicionar usuário, né? Então passou por tudo aqui, contemplou todos os cenários a partir do coverage, né? Meu código foi executado a partir disso.
100% de cobertura.
100% de cobertura. Só que aí, vou lá...
Ou será, né?
Será? Vamos ver. Será que está contemplando tudo mesmo? 100% de cobertura e está dando bug em produção ainda. Então, eu vou executar o striker aqui. Ó, aqui vocês já podem ver que ele achou dois arquivos para mutar, né? E desses 2 arquivos, ele criou 25 mutantes. Então, os testes vão ser executados em cima desses 25 mutantes, né? Que seriam versões do meu código com mutações, com modificações, com erros forçados.
Mudanças aleatórias, assim, arbitrárias no código, né?
Exatamente. Essas mudanças você também pode pré-configurar aqui na ferramenta, se você quer só boolean, se você quer só conditional expression, se você quer só... Então isso você pode configurar, mas aqui eu deixei misto, né? Então podem ver que...
Ele salva os mutantes também, Lucas?
Oi?
Ele salva esses mutantes?
Ele salva numa pasta temporária, né, esses mutantes aqui, mas é só para tempo de execução e para gerar o relatório, e depois ele vai mostrar no resultado quais que foram as mutações que sobreviveram, né? Então, aqui vocês podem ver que mesmo com 2 arquivos já demorou bastante, demorou 1 minuto. Tá certo que a concorrência eu coloquei baixa aqui, poderia aumentar algumas coisas a nível de processamento.
É muito devagar, né, cara? Compara com o que a gente estava vendo antes, ordens de grandeza aí. Né?
Exatamente. E esse é um ponto, por isso que ele tem que ser em pontos cruciais, assim, pontos mais críticos do seu projeto, aquela camada que está mais... tem uma regra de negócios mais... que você tem que garantir, né, a confiança, seriam os pontos iniciais para você ir aplicando. Então, quando eu abro aqui, ó, por exemplo, aqui aqui ele gera um relatório disso, e ele gera um mutation score, onde ele faz os cálculos baseados nos mutantes que eu matei, os que sobreviveram, se deu timeout também, se o teste demorou muito tempo para executar, ele também influencia isso para contabilizar na qualidade dos seus testes, se ele não está sendo coberto.
Dá para aumentar, Lucas, a fonte aí?
Dá sim.
Funciona Ctrl mais aí. Aí.
Boa? Aí.
Uhum.
Beleza. Então aqui temos, ó...
Essa é uma série de deep testing para galera assistir no metrô, assim, no celular, entendeu? No ônibus.
Sim, sim, faz sentido. Tem que ser responsivo.
Você que está assistindo no metrô, depois coloca nos comentários aí, nos avisos.
Boa.
Exatamente. Bom, então, como nós vimos, no meu coverage estava 100%, mas tem coisa errada aqui, né? Tem cenários que eu não estou cobrindo. Então, por exemplo, se eu vier aqui no próprio do Can Accept Terms lá, que eu estava verificando, então ele testou essas duas mutações, ele colocou um maior ou igual e colocou um retorno falso direto, e o meu teste continuou passando. Então, eu teria que cobrir com esses demais cenários que não foram contemplados. No Add User aqui, por exemplo, vou mostrar aqui só os testes aqui também. Aqui tenho dois mutantes que sobreviveram. Eu tenho uns testes aqui. Deixa eu só mostrar no Add User Test.
Perdemos a oportunidade de um mutation versus generative, né?
Pois é, né? Como seria a combinação dos dois, né? Eu acho que ficaria um pouquinho pesado, mas dá para tentar, né? Mesclar os dois. Bom, aqui eu tenho um teste que é só para verificar. Eu vou adicionar um usuário, vou verificar se a senha dele é muito curta, é muito fraca, né? Basicamente. Então é a única coisa que eu estou cobrindo desse cara. E dentro do meu código aqui eu tenho uma parte que é para verificar isso. Então ele gerou mutações em relação a isso, né? E aqui uma das mutações, ele testou menor ou igual e continuou passando o meu teste. Então, peraí, eu modifiquei e ainda assim continuou passando. Um outro caso aqui, ó, que passou no coverage, mas ele pega também no teste de mutação. Por exemplo, aqui eu tenho uma validação em que não pode ser vazio o papel do usuário, o password e o username, né? Então, só que se eu for nos meus testes lá, deixa eu voltar aqui, eu só tenho um teste que está validando isso, que é se o username é empty. E vejam que mesmo assim ele passou pelo meu coverage, né? Ele estava 100% coberto. Então, como que eu acabaria com esses mutantes, né? Eu teria que adicionar aí mais testes. Lógico que teria para trabalhar para não ter repetição de código e tal, mas eu deveria adicionar mais um teste para o password e mais um teste para role. Aí eu cobriria mais cenários, porque aqui a gente está numa lógica simples, né? Mas pensem em umas lógicas complexas, onde basta mudar um operador lógico ou passar um campo que está sendo validado para mudar totalmente o comportamento do sistema, né? Então, por isso que é importante a gente contemplar esses demais. Então, se eu for executar aqui novamente,
você pode falar, Lucas, qual foi o módulo, né? Qual foi o módulo que você cobriu?
Sim.
Análise de mutantes?
Sim, a gente focou em dois principais do app que a gente está trabalhando atualmente, que foi a parte de pagamentos. Então, é uma área do app de pagamentos e a gente tem os testes que a gente executou em cima de React Native e também na parte do back-end do Node foram relacionados à parte de pagamentos e também a tela principal, onde é a que tem maior carga, o maior volume de acesso. Foi por onde a gente começou, né, nesse aplicativo que a gente tem, para aplicar isso. De início, não aconselharia tipo, já colocar numa trava do CI. Né? Você começa com uma análise mais geral, se quiser você pode executar em cima de todo o seu teste, né? Vai levar aquele tempão, mas é bacana até para você ver o tanto de... É até uma coisa engraçada, a primeira vez que eu apliquei isso em um projeto, eu não tinha calibrado muito bem a ferramenta, não tinha feito as configurações certas, apareceu uma horda de mutantes no meu código ali. Eu falei, vou jogar tudo fora, não sei escrever teste, mas depois que eu descobri que faltava algo na calibragem ali mesmo da ferramenta, daí eu fiquei um pouco, meus testes não são tão ruins assim. Então aqui, ó, adicionei, né? Deixa eu voltar aqui pro relatório. Atualizar, ó, aqui eu já contemplei e já aumentei meu score. Então com isso eu consegui aumentar a qualidade e a confiança sobre o meu código. Né? E se fosse para fazer para o password também, eu teria que executar testes aqui também, que contemplassem, não só quando está com a minha senha com um número de caracteres pequenos, mas também tipo, quando passasse de 5 ou quando fosse igual, para conseguir contemplar todos os cenários, né? E é bacana, se fosse com o teste generativo ainda, poderia fazer com diversos tipos ainda, se envolvesse criptografia ainda no meio, para a gente garantir que não quebrasse em nada em relação à senha que o usuário inseriu. Bom, basicamente é isso.
Muito
Não sei
bacana.
se vocês têm alguma dúvida em relação a mais.
Mas alguma história recente aí, tipo, uau, e a gente ia ter esse defeito vazando para produção e a gente pegou no negócio de pagamentos, o cliente está indo ao delírio, que não foi um bug de produção de pagamento. Tem alguma história com essa cobertura?
Tem histórias da gente pegar testes mesmo em cima, não diretamente o bug, a partir de um bug a gente depois pegou esse mutante vivo, né? Mas sim de testes que realmente não estavam testando o que era para ser testado efetivamente. Então, muitas vezes passando por refactors ou durante o desenvolvimento, a gente identificava alguns testes que não estavam sendo contemplados, não estava testando aquilo que é de funcionalidade mesmo da minha aplicação. A gente tem a figura do dev espertinho, né? Que muitas vezes, que nem eu falei, quando você só tem como parâmetro o percentual de coverage para dizer se você está aplicando com qualidade ou não, muitas vezes existe aquela figura do dev que só cria um teste só para continuar em cima do porcentagem que eu desejo, né, para minha aplicação de coverage. Então, e não quer dizer que isso tá testando efetivamente aquela funcionalidade que eu quero, não está garantindo isso.
Então, muitas vezes a empresa investe em testes, mas ela não sabe, cara, esse tanto de teste que eu estou fazendo tá bom, tá ruim, tem que fazer mais, tem que fazer menos. Uma primeira tentativa de chegar nessa resposta, né, cara, será que isso que eu estou fazendo de teste é suficiente? Foi o coverage, né, a cobertura, mas a gente vê que não é uma medida muito boa, né, e acho que a análise de mutantes então dá essa resposta mais precisa, falando, cara, a efetividade dos seus testes são X%, né, a análise de mutantes te dá isso mais...
Sim, ele vai avaliar a qualidade dos seus testes mesmo.
Animal.
O teste do seu teste.
Pessoal, vou switch over to English just because I want to involve David in the conversation, ask a question around this. So what I'm seeing is, okay, coverage, as Klaus just said, started on the paths through code, right? That's one of the important things to test, that you can go through all the paths, including the unhappy ones. And now with this like mutant generator thing, first, is there a risk of developers or managers gamifying this? Is like it's now a kill the mutant game, and you just get, for every mutant you have a ticket, and the more mutants you kill, you get promoted. But beyond that, now we're talking about coverage of the data, right? So testing is also about the data. Do we do what we want to do with the data there? Which goes back to how we can use these two techniques together, maybe. But what do you all think?
I appreciate the distinction that you're making between sort of code coverage and data coverage, and that's one thing. I'm not sure whether Lucas, maybe you can speak to this, but does the mutation testing? It's mutating your code not so much like the inputs, right? So it doesn't increase your confidence that it can handle a wide array of inputs. You still need to have tests to prove that, right? So if that's true, then yeah, I'm sure these can work together well. I don't know of a mutation testing tool in Clojure. Do you know if there's one that exists?
I found a few searching the web quickly for Clojure mutation testing, and there's one called Awesome Mutation Testing. I suppose this one is good. What you think?
It's awesome.
It sounds awesome.
Awesome.
Yep.
It's not even its middle name.
And if we can go back to some of the generative testing and stuff, do you have examples like of recent real world application that you can share?
Yeah, unfortunately, I'm experiencing technical difficulties, so I'm going to talk. My mouth is functioning properly.
So that wasn't working, but I have a time machine here, and we can go to the future. And there we go. I think your example is going to work now.
I think it might. see. All right, so we have this tool that we use at Nubank called Sashing, which at this stage is not open sourced, but I think it's a pretty general useful tool, and I know there's been conversation about it. But the reason I bring it up is just because this is a great example of how we can use generators in a different way. So what we do is, let's say that we have two services, and one is going to send an HTTP request to the other one. And we want to, when we're running our tests locally, you know, we had a world years ago before I joined the company where we would do these end-to-end tests where we would set up a bunch of services in a in like a staging environment, and then run tests that way. And as the organization grew and as the number of services in play grew, and as the number of people trying to use this system grew, it just became not workable for a variety of reasons. One is just maintaining it. You know, if you're relying on systems that other teams are actively developing, on services that other teams are actively developing in the same environment, they might break you and you don't know why. So out of that experience came this approach, which is that what we do is we define schema for what the service that's producing a response has, right? So here I've got this example here where we're defining a schema and I'm calling it out. So this is, you know, like an HTTP, the body of an HTTP response. And then we can, since we're defining a schema for it, we can generate from that values, right? And you can see I'm just generating. And by the way, you'll notice that the fruit, we've got two fruits, mango and lemon, and you can see in the results, sometimes it's going to be a mango and sometimes it's going to be a lemon. That's important, and I'll explain why shortly. Then here we're defining a schema for the input, which looks a lot like the one for the output, and I'll leave it that way for the moment. And here, you know, I could generate values from that, and you can see that these values look a lot like what we got from the output. So the input schema is the schema for the service that's making the HTTP request, and the output schema is for the service that is responding to it. And so notice that we're using this function called strict schema for the output. And then we use a function called loose schema for the input. So what these mean is that the output schema, we're making a promise that this is what we're going to produce. The input schema, we're saying we want this stuff, but if you give us anything else, that's fine. We don't care, right? And so what that allows us to do is the service that's providing the information can add new things to the schema, and it won't break the contract. Does that make sense, what I've just said so far?
Yep.
All right, so
the loose schema, for example, if the loose schema gets an ID that is something different than a UUID, it will break, right? It won't allow that.
That is correct.
Okay.
And we can test that out. So let's say that the people working on this decide, hey, you know what? Let's just make this a string. So now I'm gonna, well, I didn't run the test. First, let me run the test once so you could see what happened. There we go. I hadn't reevaluated it. So it passes, right? But now we'll go in and we'll change the output schema to produce a string. And then when we run this, you could see, okay, value does not match schema. right? And it's specifically saying this value, the string Abbott, is not an instance of a UUID. So it tells you a lot of information about like what you're trying to understand. So that's one way that it'll fail and correct and give us valuable information. On the flip side, if we were to remove a key, like let's say we decided to remove the description, that should fail, right? And it does, because you could see now missing key required, or missing required key. And then further down, does it tell us which key is missing? It does not. Oh, desk. I'm sorry. I was reading that as like the output's description, but actually it's the desk key that's missing. Now on the flip side, if we decide we don't care about the description anymore, right? So we're not going to include that in the schema for the service that's making the request. That's fine. The fact that it gives us a description, we just don't care. And then let's say one day they say, you know what, we're not serving lemons anymore. Now in this case, what do you think is going to happen? What do you think should happen? Should this fail now because we're not getting lemons anymore?
It should be okay.
Why should it be okay?
It's either mango or lemon.
And mango is still valid. And
it's still valid. It means that whatever our service was doing with lemons, that's never going to happen anymore because we're never getting lemons. And so maybe there's a conversation missing, but the software still works, right? And so sure enough, that still passes, right? Now on the flip side, let's say, hey, we don't care about mangoes anymore. We only care about lemons. So now our enum is only lemons, right?
On the input side.
On the input side. Now we get a failure, right? Because it's never going to give us the thing that we the only thing that we want.
What is this hashtag underline you put there on line 22 and line 12?
Oh, that's in Clojure, a way to comment out the next expression. Okay. So it could be a whole expression. It could be just a value.
Okay. It's a comment.
It's a comment
expression.
Yeah. So that's that. And I mean, this is a great tool because each side of the conversation can work independently, and this tool Sashin keeps track of all of the services have a way to publish their schema for different endpoints, and also for queuing for messages that go on a queue.
So why can't they use a simple like contract comparison? Why do they have to generate all these values?
I'm not sure I understand your question.
I could simply compare, right? The input schema and the output schema, and can see the keys are there and the enum is
because
okay,
the schema are I'm using examples of schema here that are they look sort of type-based, but these schema can be more complicated and have arbitrary functions that constrain their values or expand them in some way. Okay. So it's not, when we were talking about this before, I think you brought up the question of types, and it's not really types in that way, right? Because the schema, so the tool we're using here is Prismatic Schema, and it comes with generator capability. The other tool that's common to use is Clojure Spec, which also has generator capability. And in either case, the specs themselves or the schema themselves are not limited to the types of the values. So we have a tool that we use at Nubank called Sashin. And this is an anagram for schema. And part of the culture here is that we create schema using either the prismatic schema library or Clojure spec to define data structures. And so the way this tool works is that we're all committed to creating these schema definitions for anything that's going to go over the wire, whether that's going over HTTP or if it's going over some messaging queuing. And we've got, there are two sides of this conversation, right? There's the producer and there's the consumer. And so what we do is we have this concept of strict schema and loose schema. And there's this what is it, Postel's law? Is that what it is? The tolerant readers, be strict in what you produce, but be lenient in what you accept, right? And so the idea there is that the producers will say, I'm going to give you a data structure that looks like this. And the consumers can say, I can accept all kinds of data structures. I'm interested in these particular bits, but if there's more stuff in it, great. I'm going to just ignore it. And so we create these schema from which we can generate examples using these generators. So both Clojure spec and prismatic schema have ties into generator libraries, which are actually, it ties into that tool I was showing you before, Clojure test check. And so if you write a schema, you can use it to generate an example. So what we can do is, on the producer side, we can say, okay, we're going to generate example data of what we might send over the wire. And then on the consumer side, we could say, okay, we're going to take that and we're going to validate it against our consuming schema. And the important thing here is that the consuming schema is tolerant. It will accept things that it's not interested in. So if you have extra keys, basically that in a map, if you have extra keys, like, we're going to just ignore them. So what does this give us? What it means is that, you know, we have a lot of microservices at Nubank. Got any numbers on that, Freire?
They're always out of date, but it was something like 300 last time I checked.
Okay, so we're measuring it in hundreds, not in dozens, right? And these are all maintained by a lot of different teams. And if you can imagine the coordination that would be required if one team, let's say that there is one team that produces information that two other teams consume, and one of the consumers needs some new information added to what is produced. And so they collaborate with the producers of this information. The producers of this information add it. And now all of a sudden, the other consumer is like, they're getting all this new information that they didn't ask for and don't know what to do with. So by setting up our tests this way, where the consumer can ignore anything it doesn't care about, we get a lot of benefits. So one is that whole transaction can happen without the second consumer having to change a thing or care. And the other thing that happens is, if somehow that exchange between the first consumer and the producer resulted in a breaking change for the other consumer, it would be revealed when we run these tests. And that I've seen that save us from deploying things into production. We have this project that I'm working on now where we send information to another service and it sends us back information. This is all over Kafka, right? And so this is it's just a message that's produced, and then we consume the message coming back the other direction. And the thing is that there are dozens of other consumers of this very same message. This is a message that goes to our the service that manages our savings account and says, hey, I want you to store this money in a savings account. And then it sends out a message saying, hey, we stored some money. Now, we only care about the one that we sent, but we're consuming like all of the messages for storing money, or like saying that money got stored. So, and there are other services popping up all the time that interact with this. And so what we do is we send a key that says, okay, we're the source of this message. And then when we're consuming, we only look at the ones where we are the source of the message, right? So what happened? Well, we submitted a PR to this other service and we said, hey, we're going to be a source now. And when you do that, you have to register it loosely, like you have to add it to the code base of the other service. So we did that. And then that all went fine. And then we made some changes in our system to like store the money and consume money stored. And we discovered that we had actually had a typo in what we gave them for us as the source, right? So we made this pull request in another service. They merged it. There's no tests that say that. There's nothing talking to anything yet, right? But as soon as we added it as a consumer to our service and then ran these tests, it failed. And it failed because it never produced our service as from the, okay, going back now, remember that we generate examples now from the producer side. None of those examples had our service as a source. And so our test failed. It's like, oh, what did we do? And then we went and we looked and it wasn't exactly a typo. We had been debating about names. That's something I think all of us do from time to time. And
the person who wrote the code, there was one side of the debate. The person that wrote the test was on the other side of the debate.
Yeah, something like that, right? And it's not so much that, it's just a matter of things happened at different times in the course of that debate. And so by the time, like the debate went on, and then we made a different decision. And then, but we learned about it before we got anywhere, right? And this is something that's completely automated, right? As long as when you're implementing the service code, there are some rules that you have to play by, which is you expose the schema using a standard pattern for doing so. And then there's a system that we have, this sashing tool, that looks at your PR and says, okay, I can see that these are all the other services that you, well, actually for messaging, it's like, these are all the topics that you consume on, and these are all the topics that you produce on. Who is producing what you consume? And it goes and finds the producer. And then who are all the consumers for what you produce? And it goes and finds all of them. And then it runs all these tests by generating examples from the schema and validating them against the schema on the other side. Does that?
So the sashing run is always generative?
Yes.
Oh, okay. I didn't know that. Okay.
Yeah, there's nothing hard-coded about that.
Does it use pre-generated examples, or does it generate the examples at every run?
There's some caching.
Okay.
And I don't actually, that's gone through some changes, and I don't know exactly how that's managed. But I think it's effectively, it keeps track of who these conversations happen between, and when one side of the conversation changes, new examples get generated.
because the predicates for describing the data structures, they are arbitrary. They are like any code. They aren't a specific language. So you can't really statically check them, you know. So
No,
I
it's
didn't know
not like
it was.
right.
I didn't know it was by generating examples. Interesting, very nice.
Yes, yeah. So that's an interesting feature of both of these generator tools that I was talking about, is that you can customize generators. So, and you can do so with like anonymous functions in Clojure. And so obviously we can't deal with that in any static way.
Mm-hmm.
And going back to Lucas, you didn't share if you had a recent, like, oh no, and then we found this bug in the payment logic with this stuff. Would you like to share one of those recent wins?
Com testes de mutação?
É esse que você está mostrando pra gente, tipo, salvou vocês recentemente?
Bom, como eu falei, né, o que a gente pegou, a gente antecipou algumas falhas, foi do que de melhor a gente extraiu, né, da ferramenta, né. Então, acredito que sim, teve algumas situações que não estavam contemplando algum tipo de cenário e que o usuário, e se a gente usa em conjunto testes end-to-end também, né, para pegar algumas situações, né. Então, teve questões de cenários que não estariam contemplados e que às vezes gerar muita intermitência dos meus testes end-to-end, né. Então a gente acaba antecipando essas falhas até para um passo antes do nosso teste do end-to-end, né. E seriam etapas em que o usuário, na parte de pagamentos, conseguiria um fluxo que não estava contemplado dentro dos nossos testes unitários, né. Então, em alguns casos, a maioria a gente antecipou, mas alguns a gente consegue ver que lá para frente também, testando manualmente ou no teste end-to-end, se a gente não tivesse feito aquele teste garantido que uma modificação ocasionaria um efeito colateral naquele trecho do teste, né, isso traria consequências para o usuário final, né? Então a gente acabou cobrindo esses cenários também para não ocorrer isso com o usuário final.
Você vê mais como uma ferramenta para desenhar e tipo, informar os desenvolvedores quando você está pensando na cobertura ali, na hora que está escrevendo os testes? Ou como que vocês usam mais?
Sim, a primeiro momento, sim, é mais para a gente instruir, também é uma forma de instruir, né, desenvolvedores a aplicar os testes de maneira correta, né, contemplando os mais diversos cenários. Então, a gente utiliza mais como para ela te dar essa visão de que às vezes o seu teste só tá priorizando o coverage mesmo, não tá testando aquilo que é de funcionalidade mesmo e que pode ter um efeito colateral, né, mais para frente. Seja um exemplo de regra de negócio, um exemplo de funcionalidade de dentro do código. Então, a gente usa mais para dar essa visão mesmo da qualidade dos testes e trazer esses core dos testes que nós estamos aplicando.
Você sentiu alguma vez que te ajudou a simplificar o código? Tipo, o código está complexo demais, cara. Aí eu posso meter um monte de mutantes nesse negócio que, cara, vai continuar passando os testes. Aí, cara, se eu simplificar o código, não tem onde enfiar mutantes nesse negócio, entendeu?
Sim, muitas vezes você até identifica nos timeouts que são que ele traz ali, né? Às vezes o código está mal escrito, vai demorar, ele impacta até diretamente no tempo de execução dos seus testes. E como ele demora, os testes de mutação já tem um tempo alto de execução, às vezes a gente consegue identificar isso também, né? E se você não simplificar o seu código, vai ficar mais difícil de você conseguir cobrir esses cenários, né? Os mais diferentes cenários que que as mutações vão gerar para você, né? Então, o código não testável, digamos ali, vai ter mutante a rodo. Vai ter muito mutante ali. Então, acaba forçando também a refatoração, a você construir um código mais desacoplado, né, aquele código testável e mais apto a fazer refatorações também.
Você sentiu que os times que estão usando isso, ou pelo menos nas áreas que estão aplicando, o código tende a ser funções menores mesmo? Só para... Não, aqui não dá para ter muita mutação, se tiver...
Sim, tem áreas que tão bem difíceis, varia muito de projeto, tá? O projeto atual que a gente está trabalhando, a gente está num processo, a gente pegou só para passar um contexto, é um projeto de código legado, né? E a gente está passando por um processo de refactoring. Ele é um código que estava difícil de ser testável, né? E com isso a gente está colocando, aumentando a cobertura para a gente. A cobertura, quando eu faço essa comparação, não quer dizer que a cobertura não seja importante também, né? A gente é um aliado nosso no coverage, mas tendo os testes de mutação para a gente verificar a qualidade dos testes que a gente vem aplicando, isso também ajuda. E sim, a tendência dos nossos refactors sempre estão sendo de trazer as funções megazords que temos, né? Trazendo para um contexto menor, mais desacoplado, onde seja mais fácil de testar, e a gente consegue fazer isso, inclusive, nos próprios testes, né? Tem testes gigantes testando várias asserções, e a gente acaba simplificando os testes para contemplar mais cenários, ao invés de fazer aquele teste que não tá sendo aplicado o clean code, né? O teste tem que testar uma coisa só ali, né? Não pode fazer várias asserções. Então, nessa ferramenta também ajuda a gente a aplicar qualidade nos códigos que a gente desenvolve.
Muito bacana, very cool.
Of course, you translate the one thing that I understand.
Yeah.
Eu tô curioso para aplicar ambas as técnicas, Generative Testing e Mutation Testing também. Em Clojure, eu acho que é mais fácil de aplicar mutantes, right? In Clojure, I think it's easier to do mutation testing because the code is represented as a data structure already, so you don't have to, parse code and abstract syntax trees and stuff like that. It's just data structures. So that will be nice.
I imagine so. I haven't looked at the tools, but I'm sure that they take advantage of that fact.
Mm-hmm.
Yeah.
Sobre testes generativos, eu vi pesquisando, né, em alguns fóruns também, o pessoal comentando que tava uma discussão onde um dev trouxe, né, por exemplo, que pode trazer instabilidades, né, por conta da questão randômica da geração dos nossos testes. Aí o outro cara respondeu: mas não é um problema a instabilidade. A instabilidade, ela identificou que tem um bug no seu código, né? Então, o problema está no bug que foi encontrado no seu código. Então, porque tem vezes que acredito que você possa executar e rodar tudo com sucesso, né? Tem vezes que, dependendo do random ali, ele vai executar algum teste com falha. Mas tem um bug ali que deve ser resolvido. Então, nessa parte aí, é bem bacana também a forma como ele vai lá a fundo num cenário que, tipo, nunca que ia imaginar que ia falhar um teste, né?
So I love to hear your perspective on this, David. So Lucas is telling us about the debate where, well, I'm unlucky, and in one of those generations, just the examples were very simple, couldn't show any bugs. So it's like the confidence of developers on these generated examples in terms of like, oh, maybe the set just didn't test anything. It was just the simplest data that would pass.
And also flakiness. The guy was saying, a guy was arguing in a forum that generative tests can bring flakiness to your tests, because sometimes they might pass, sometimes they might fail.
Well,
And Lucas would say, of course, the good thing is that they found a bug, right?
Right. It's not guaranteed to fail every time, so you have a number of knobs that you have control over when you're doing generative testing, and one of them is the number of tests to run. There's another concept of size, which it's sort of a relative concept. So you can say, I want to generate really big examples, or I want it to generate smaller examples. Or the more examples you generate, the larger they get by this concept of size. And size could mean, in a simple example, like just a sequence, just the number of elements in the sequence. But in some kind of nested structure, it might affect how deeply nested it is. This kind of thing. So you can start off with really small examples, and then they get progressively bigger. Naturally, generating big examples takes more time. And generating more examples takes more time. So when you're developing with this, you might run your tests and say, hey, this one test is taking too long. How many examples am I generating? Oh, I'm generating 1,000 examples. Maybe 50 would be enough to get the point across in this case, and then you just make a value judgment. I think the default is 50 or 100. In the generator, when that def spec tool that I showed you before. But sure, you could get unlucky and it could pass, and then one day suddenly it fails. But then when it fails, you have the seed, you know how to reproduce it, and you can go investigate it.
Hey, could you give some real life examples of properties? For example, addition has this commutative property, but not everything has like tools. We know these properties and so on. What would some real life properties be like that you can check?
So another example that I've used when I've talked about this is like a temperature converter from centigrade to Fahrenheit, and so any kind of calculation that does some kind of conversion from one concept to another, like a great, if you have the reverse, right? So if you have the centigrade to Fahrenheit converter and you have the Fahrenheit to centigrade converter, a great test is that it round trips correctly. Right? Okay,
round trip test,
And this is something that on occasion, I will introduce a pretend opposite direction calculation just for the ability to do that.
Cool. Okay.
Even if it's something that we don't use in our production.
My fear is like the property implementation, simply repeating the business logic. Redundantly, like copying the business logic.
Well, no. So if you think of, we talked about, well, you started this with, it might not be so clean as it's commutative. I mean, those are the kinds of things you want to look for. So, that example that I just gave you about the conversion from centigrade to Fahrenheit. So we all are probably familiar with the most famous numbers in that conversion, right? The freezing and boiling points. So you can have a couple of examples that show that those work, right? And then in terms of, what's a general property you can say about it? Within some range, all of the Fahrenheit values are greater than the centigrade values. And it turns out that range is also well documented. At the point of parity is -40. So -40 Fahrenheit is equal to -40 centigrade. Every value above that, the Fahrenheit value is greater. Every value below that, the centigrade value is greater.
Okay.
And so these are general statements you can make. Okay, in this wide range of inputs, this property can be true. Now, by itself, that doesn't give you great confidence, but combine that with these famous numbers, these three specific examples, and now it starts to give you confidence, like it's working correctly. And then there's also, it's working correctly with the famous numbers, the famous examples, and it also fulfills these general properties. There's another cool technique where, let's say that what you're trying to optimize some calculation, right? It's coming up with the right answers, but it's performing badly. So you come up with this implementation that's much more convoluted and complicated, and you want to know that you're getting the right answers out of it. So there's a technique, I think it's called a test oracle. And the idea is that basically you generate a bunch of inputs and you say, okay, does my simple implementation produce exactly the same outputs as my complex implementation?
Very nice.
Right? And now you have some confidence that, because you could look at the simple implementation and look at it and say, that's right. And I can see that it passes these tests. Now, if I give it thousands of values, am I getting the same answers from both? And now you have a lot of confidence.
Very nice.
So it report. I'm getting.
You're breaking up there a little bit.
It supports. My audio is terrible.
There's echo signals.
Oh, I wonder if sometimes that's me. I'll mute.
I guess what I was going to say is that it supports your exploration there. So the examples give you that confidence, and with the generation, just like TDD is a lot of, to me, about refactoring, right? With this, you can also rewrite with confidence. You're not refactoring anymore, you're rewriting, but because the example set is not limited to your few examples, you get that confidence on the rewrite matching the functionality of the original.
Sure, although, I mean, when you talk about refactoring, I mean, you get the same benefit as having, if you think about the artifacts you're left with if you're doing TDD, you know, you have a bunch of examples, and now you can refactor with some confidence. Well, the generative tests give you that same confidence, right? It's just you didn't hand code the examples, they're generated for you. What I will say is that, like, if you think about, you know, the classic TDD exemplar is the bowling kata, if you remember going through that ever. And I played around with trying to get through that using a more generative approach, and it didn't work that well when I tried it. So, you know, I could imagine, you know, if you're really trying to build up an algorithm a little bit at a time, developing it using a TDD process, then writing some generative tests that prove all of everything that you already asserted in your 20 examples in 1 or 2 generative tests, and then throw away the other examples. I'm saying that out loud, and I will be called heretic by some people I know, and that's fine.
Just don't send them the link; they don't have to watch.
So we discovered you are a villain, actually.
Yes.
You are a villain after all.
After all.
Awesome. So thank you so much, Lucas. David, it was really insightful tonight.
Yeah, I'm really looking forward to listening to and watching the words that had come out of Lucas's mouth.
Melhorar meu
Okay, my friends, good night. Thank you very much. We close another episode of the Deep Testing series, Beyond Automated Testing, Beyond the Basics. Thank you very much.
Thank you. Foi um prazer.
Thank you. Foi um prazer também. Muito obrigado, pessoal.